Okay, so 5.8 quadratic inequalities. I want to kind of refer it back to like simpler inequalities, back what you guys did in Algebra 1 and stuff, so we can kind of remember how that worked and see how it fits into this new stuff. So how would you solve a little inequality like that? So again, first thing I guess when we think inequalities, greater thans, less thans, okay, it's not an equal sign, it's not an equation. So the answers are a little bit different. We're not going to get like x equals something. So how did we do something like that? X plus 3 is less than 5. Okay, just solve for x just like it were an equation, right? And get x is less than 2. Okay. So how is this different than the answer to an equation? Okay. Yeah, there's a whole bunch of possible answers, right? X can be any number less than 2. Okay, it could be 1. Could be 0. Could be negative 400,000. Could be 1.999. Okay, like anything less than 2 is going to work. Okay, so if we were to show all the numbers, remember you graph it on a number line, and you say that it's an open circle at 2 because it cannot exactly equal 2. There's no equal, it's just strictly less than. So not exactly 2, but anything less than 2, anything that way, all of our solutions will be in that interval of numbers. Anything less than 2. Okay, so what I'm getting towards, or 2 at the bottom there, the solutions to inequalities are actually intervals. It's not just like one number or two numbers. It's a whole region or a whole interval of numbers. Okay. So when we start solving quadratic ones, they're going to be intervals as well. We're not just going to get x equals 5. Or we're going to get something like x is less than 5, something like that. Okay, so that little refresher. Good? Okay. All right, so let's do an example of a quadratic. Okay, and there's going to be a couple methods to do this, and we actually need to kind of know both. I'm not trying to just like throw a bunch of methods and throw, confusion on top of what we already are, but both methods are kind of necessary. Okay, and we'll see why in just a second. Okay, so let's say we have something like that, x squared plus x less than or equal to 2. Okay, let's do it without the graphing method first. Let's do like solve it using algebra. Okay, so we would solve it just like as if it was an equation. Okay, so if that less than or equal was an equal, let's solve it. That's going to be your first step. Yep. 5.4 to 5.8. Okay. Thursday. Okay, so we would solve this as if it was an equation. Okay, that's kind of what we did on the one on the warm-up, right? We just pretended like it was equal sign in there. Now this one's a little more difficult to solve, but we have all those methods, so we could try like factoring or something, right? Let's try factoring. Let's get it set equal to 0. So can we solve the equation x squared plus x minus 2 equals 0? Okay, we have a whole bunch of methods from early in the chapter, right? Factoring that one can be fast if possible. So let's see, can we factor this thing? Can we get two factors of negative 2 that add up to positive 1? Yeah, 2 and negative 1, and which one? Yeah, positive 2 and negative 1. Yeah, we said that, right? So x plus 2, positive 2, and then x minus 1. Let's make sure those meet both conditions. Okay, those do multiply to get you the negative 2, which was the c value, and they do add up to the b value. Okay, so I think that works. So if factoring works, it's probably your best bet, so I would go with that. Now if we couldn't, what would we have to rely on? Graphing or completing the square or quadratic. Yeah, so we got all those other options that always work, but are a little bit longer sometimes. Okay, so to finish this, we set each factor equal to 0, we can get our two solutions. Okay, so those are going to be values we're going to use. Those aren't the answers now, because our problem wasn't just the equation, it was the inequality. But we're going to use those. Okay, and here's where it's going to be a little bit new. And this method we're about to do will work on any inequality ever. Okay, you guys go into calculus and beyond, and you have this crazy inequality. This process works always. And it's actually, we did the process on the little small one on the warm-up. We just didn't really think about it, but we really did. And we can go back and look at that in a second. But here's what you do next. Plot those values on a number line. Okay, these two answers that we got, we call them critical values. Okay, they're going to get plotted just on a number line. Okay, and you don't have to be super accurate when you do these. Just make sure you put them like in the right order. Like the -2 needs to come first because it's farther left on the number line. +1 up here somewhere. So again, just make sure they're on the correct side of each other. Negatives are always left. Bigger numbers are always to the right, that kind of thing. Okay, and what happens is these numbers divide the number line into three different intervals or regions. We got one group of numbers on this less than -2. We have a second interval in between the two numbers, and a third interval for all the numbers bigger than 1. Okay, and our final answer is going to be one or more of those intervals, or possibly none of them, but those are the things we need to check. Okay, so is it all the numbers less than -2? Is it the numbers between -2 and 1? Or is it all numbers greater than 1? Or some combination of those? Okay, so here's where we're going to test some points. Okay, like if you guys remember when you tested, you did a test point, like you test 0, 0 on a graph to see if it meets the inequality and you would shade a side earlier in the year. Similar here. Okay, this is step 3. We do the interval test. So we need to check a point from each interval and see if it makes the original problem true or not. Okay, so you get to pick which point you want to test. So you usually want to use nice numbers. So if we want to pick something from interval 1, what would be something nice to test? Any number less than -2 we can try. So just pick something kind of small. Use like -3. Okay, but you can use any number you want that's in that interval. So I'm just trying something from here, any number you want. So if I put -3 in, again, I want to go into the original problem up here and see if it's true or not if x is -3. Okay, so let's check it out. Remember the original problem was x squared plus x. What was it, less than or equal to? Less than or equal to 2. So I'm going to plug -3 in, see if it works. -3 squared plus -3, is that less than or equal to 2? So it's going to be a yes or no thing. It's either true or it's not true. Okay, question? Just when you do it in a calculator, it's best to do it this way so that it knows you're actually taking -3 and you're like squaring that number. If you didn't put the parentheses, or if you put this on the inside, it might just think that you want the opposite of like regular 3 squared, and it's going to give you -9, but it really should be +9, right? Because a negative times a negative should be a positive. So this is going to be like +9 plus -3. It's going to end up being 6. And is that less than or equal to 2? Clearly not. Okay, so that means that any number in that interval is not a solution. So this whole interval was like a no. Those numbers do not work. Okay, and the good thing about this interval test is you only have to test one number in there, and it tells you what will happen with any number in there. So the whole first interval is no. Okay. Now we got to check the second interval. Any number we want to try between -2 and 1. So what's a nice number to work with in between those two? 0. 0 is a good one. Or you could use -1 or anything. Anything in between there. I'm going to use 0 because 0 is usually easy to calculate with. So if x were 0, 0 squared plus 0, is that less than or equal to 2? Yep. 0 is less than or equal to 2. Okay, so numbers in that interval will work. We showed one of them works. That means they will all work. Any number that's in between -2 and 1 will make our problem true. So those are solutions. Okay, and then we just have one more interval to check. I need to check what about all the numbers that are bigger than 1? Let's test something in interval 3 like the number 2. And let's see if that works. So again, plugging 2 in for x. Is 2 squared plus 2 less than or equal to 2? Not sure why that changed to red, but that's okay. So that one didn't work, right? So that means any number up here bigger than 1 is not going to work for us. And most of the time it seems like it's just going to be one of the 3 regions. Okay, but you still want to check all 3 because there are times where like 2 of them will work. Okay, but it kind of seems to alternate a lot from what I've seen. But there is a reason for it. Sometimes they all work, or sometimes 2 of the 3 work. But so our answers are going to be the numbers from here to here. Any number in that interval worked. So how would we write that as like a solution? Everything greater than -2. Okay, so our answer or solution. So one way is to just say any number greater than -2, and also it has to be less than or equal to 1. That's one way to say that. Okay, and that's totally fine. That shows it. It has to meet both conditions. The other way, like the way the book's going to show it, is write it as a compound inequality. So something like -2 less than or equal to x less than or equal to 1. That says the exact same thing. It's just kind of more compact, a little shorter. Um, it's basically saying the number has to be sandwiched in between -2 and 1. Okay, those are the numbers that'll work. Any inequality you'll ever see. Yeah. Okay, and if we refer back to like the very first one we did, the easy one, right, when we didn't even think about it, it's kind of what we did. If you look at the way when we set it up, when we solved this thing with an equal sign in it, we got 2 as an answer, right? Okay, that was the number that went on the number line, and we had 2 intervals to check. It could either be those numbers or those numbers. Okay, and what ended up happening is if you tested a number that was less than 2, you would get a true statement with the original problem. That's why all the numbers less than 2 worked. 2 was like that critical value. But anything above 2 didn't work. Okay, so the only difference, our problems now, we have 3 intervals instead of 2. Because we have a quadratic instead of just like a linear equation. Okay, but the process will work even for the simple ones and as hard as they ever get. Okay. Now the downfall is that some problems, when you like go to this step and you try to solve it, some things can't be factored. Okay, some things don't even have real solutions. They have eyes and stuff like that, the imaginaries, and we can't really, or it's not easy to plot numbers with I as like your critical values here and test points. Okay, so sometimes the graphing method is going to have to be used. Okay, and I want to run through one like that. Okay, so any other questions on the first one though? So it's a bit of a process, a little lengthy, but you know, we won't have a ton of problems to do, just a couple to do it. But that's kind of how it's done. So let's look at one more. Okay, x squared plus 4x less than negative 5. Oh, I almost forgot. There's a name for the method we used on the last one. So let me go back for 1 second, then we'll come back because it's kind of a funny name. If you look at the first letters of the steps, solve, plot, and then interval test. This is a spit method, okay? If you don't like an inequality, you spit at it and you can solve it. Spit method. Solve it, plot it, interval test. So remember that when you get to these in pre-calc. Tell Mr. Sanford he'll like it. He likes stuff like that. Or maybe he'll have me, who knows. All right, so anyways, that's the name of the method, kind of a way to remember the steps. So back to this one. So if we did the same thing and we set it equal to 0 and tried to solve it, right? We add the 5 to both sides. Okay, so we want to try and solve it with an equation, right? So we kind of put an equal sign in there instead. Okay, we want to try and get these critical values that we're going to plot on the number line. And you might try and start factoring that. You're thinking, how can I get 5 that adds up to 4? It doesn't seem like it's really going to work too good. Right, because positive 5 would have to be 1 and 5 or negative 1 and negative 5. And neither way, it's going to add up to positive 4. So this is one of those ones that factoring is kind of out of the question. Okay, so you have your other methods. Okay, but when you're doing problems in this section, you might want to just jump to graphing on a problem like this. Okay, and I'll show you why. So let's graph this thing right now, and we'll come back and see how that can get us the answer, because it can actually be pretty quick to solve the problems too. So let's graph that guy, x squared plus 4x plus 5. Pause this for a minute. Let's graph everything. What was it? X squared plus 4x plus 5? Okay, plus 4x plus 5. All right, I'm just going to change my window back to standard. All right, so this guy looks like this. Okay. All right, so we can see, are there any solutions to the equation? No, this thing never gets down to 0, does it? Okay, it's always above it, and we never get those x-intercepts. So think about the inequality we wanted to solve, and you can actually use the graph to do this pretty quick. If you have x squared plus 4x plus 5, and we want it to be less than 0 or greater? Less? Less, okay, yeah. All right, that was like the inequality once we moved the 5 over, right? Okay, so since we can't solve it algebraically to set up the number line, think about the graph. It's asking you, which x values make the y value less than 0 or negative? Is this graph ever below 0 for the y values? No, never is. So what do you think this inequality, the solution is? There is none. This thing is never negative. Okay, it's never below 0. This thing has no solution. Right, because this specific equation said where is it less than 0, and it never is. This graph is never below 0. You can graph any of them. Mm-hmm. Yeah, you can even do graphing though for like the first one. The first one was, let's get our equation. I'm going to graph the x squared plus x minus 2, okay? So the first one we did. You can use the graph font to do these too, but I like showing you the interval method too. What was it, plus x minus 2? Okay, so this was the first one we did. And we did this the interval method. Okay, right. It does have critical values, right? And this one we were looking for x squared plus x minus 2. And this one we wanted to show where is it less than 0. Is that right? It was a less than problem? Yeah. Okay. So you can use the graph to solve that one too. Okay. This graph does go negative sometimes, doesn't it? Everywhere down here, this graph is below 0. Like think of it being like underwater. Okay. So these were the critical values that we got, the -2 and the +1, weren't they? And if we ask ourselves, where is this graph below 0? It is in between those two x values, isn't it? So it's x, that's exactly like what the number line showed. Okay, and the points up here, these were like the ones that didn't work. These values are not below 0. So these values are not what this question was asking for. So that's why our answer to the last one was in between -2 and +1. Okay, so you can kind of use the graph to visualize it as well. Okay. All right, and let's set up one word problem. Okay. Okay, so this is one of the good applications of this stuff. The quadratics is like for physics applications like projectile motion. It really follows like a quadratic or parabolic path, I should say. So let's say we punt a football. We have an equation. We want to know when will this ball be less than 15 feet high. Okay, so kind of think about it in your head when you punt a ball. It starts out pretty low, goes up, eventually gets over 15 feet, but then it starts coming back down, and we want to figure out what time frame is it less than 15 feet. Okay, so again, if you just kind of think without any of the details, it's looking something like this. Okay, the height of the ball. Okay, and this is our time in seconds. Okay, so I want to make sure everyone's clear on the equation too, because there was one like this on the quiz. The one on the back was pretty similar here. You have to plug into the equation, and you have to like understand what the equation's telling you. So x is the number of seconds. Okay, so that would be like down here in the x-axis, number of seconds. And then h of x is the height. That's really just like y. Y equals 40x minus 16x squared. So if we plugged in a number for x, like 2 or something, we could figure out how high this thing is at 2 seconds. Okay, or you can plug in anything you want for x, figure out the height of the ball. So we want to know when is the height less than 15. So I'm going to set the equation up, 40x minus 16x squared, and we want this height to be less than 15 feet. And we got to figure out which x values would make that true. Like what number of seconds would make that true. Okay, so let's get it set equal to 0, and then we'll try and graph it. So I'm just going to subtract the 15. Okay, anytime we graph it, we want it equal to 0. Okay, and then some people were asking earlier, do we have to put the -16x squared first? If you like it in that standard form, that's fine. But when you throw this in the calculator, it doesn't really matter what order things are in. But if you were going to use the formula or something, remember your a would be the -16. So just kind of keep in mind, this is a little out of order, but it's okay for graphing. So let's graph this thing and see what we get. I'm going to throw this into my y equals screen and look to see when is it less than 0, or when is it like underwater, under the x-axis. Okay. So 40x minus 16x squared minus 15. Let's get this stuff out of here. Okay, that's the thing we want to look at. Oops, I forgot my x and after the 16. 16x squared. So like that, right? All right, and let's see what this thing looks like. Okay, so we can kind of see it, but not a great view. We might want to make some adjustments to our window. Okay, and just kind of think about the x values is the number of seconds, right? Do we care what's going on at negative time before we kick the ball? Doesn't make sense in our problem. Don't worry about it. After looks like right around 2 or 3 seconds, this thing's back down to the ground. So I might make my x maximum go out to only 5 and start at 0 because I don't care about the other times. And it looks like we might just need to make the y max just a little higher to see the actual peak there. Okay, so let's look at the window. I'll make the x minimum again. This is time. I'm just going to worry about from when I kick the ball, when time is 0, not negative. Okay, the x maximum, I'm just going to change to 5. That one's not really that big of a deal. You could still see it fine. And the y max, I want to see the top of this thing just to have a better idea of it. Let's just make that like 20 or 30 or something. 20 should be good, I think. Okay, just to view it better. Again, this stuff can be different for everybody. But let's see. So that looks pretty good. We can kind of see what's going on there. Okay. All right, so again, we wanted to know when is this thing below 0. That was the inequality. We subtracted the 15 to get it equal to 0, and it was a less than problem. So I'm interested in, here's my critical values. I want to know what times is this ball down here below 0. So which x values or which seconds make that happen? So how do we find those x values? What is it? Like how do I find out what time this occurs and what time this occurs? The 0, yep. So this would be when you either do quadratic formula or just use the 0 thing on your calculator. Since we already have it in, let's use the zeros on the calculator. So let's get the 0. Let's find out when is this thing crossing. These are like the critical values. So let me get my cursor over a little bit. And remember, for your left bound, you just want to go a little bit to the left. So somewhere like that, maybe. Get right boundary. All right, so about 0.46 seconds approximately. Okay, so a little less than half a second. So when you kick this ball, it's less than 15 feet for the first 0.46 seconds as it's rising. And then after that point, it gets higher. Okay, question? If it says no sign change, it means you must not have went far enough on one of your boundaries. You didn't like pass. Okay. Okay. Yep. And try to get the other one too. 0. It's second, calculate, and then the 0. Okay. And then what was this one? X equals. Anybody get that one? It's right around 2. It looks like 2.04. Okay. Okay. All right, so again, this ball's flying. It gets to its highest point up here somewhere, starts coming back down, then just after 2 seconds, it gets back down to the 15 feet. And then after that time, it is below 15 feet. That's what our question asks. When is it less than 15? So it is, the way we would state our answer, anytime before the 0.46 seconds and anytime after 2.04 seconds. That's when it's like underwater, under the x-axis down here. So I would write that as like 2 separate inequalities. I would say x is less than 0.46 seconds. Okay, that's the first little piece, like as soon as you kick it, when it's less than 15 feet. And then there's another time if x is greater than 2.04 seconds, so after 2.04 seconds. And you could write it just like that. There's no way to write these as like one compound thing. It's got to be 2 separate statements. Okay, and that should be the same answers you get, again, if you did this with the interval method. If you used the quadratic formula, you get these same critical values, and then interval test, you should end up with these same things. So you kind of have both options to choose from. Okay. All right, and I just kind of threw in one tiny old thing just to make sure we're clear. What last part? How long would it take for this thing to hit the ground? This was like what you guys did on the last quiz. How could we find that? Yeah, and what would we have to plug into the equation for the height? Vertex to give us like the maximum. Well, we need to know when this thing hits the ground. So what's the height on the ground? 0, right? So this one you would set equal to 0. So it would be what was it, 40x squared minus 16x, and you say when is the height equal to 0, okay? And then you could just solve that using the calculator or whatever. So that is just an equation. Again, I just threw that in because it kind of fits here, but it's not the new inequality stuff. So you can just look at that if you want to. I'm not going to waste time doing that because we've covered that stuff. Yeah, that'd just be a normal equation. Yep. Okay. No, you would solve it using one of the methods from previous in the chapter. Okay. And we can maybe do that tomorrow. I just want to. C would be 0, yeah.